Welcome back to the channel, guys, and I hope you guys are doing pretty good. Today is the day 2 of our 90 days SDET interview preparation series, and I really hope that you have studied well the day 1. If we are meeting for the very first time, my name is Jatin and I help QA professionals just like you transition from manual to automation testing. In this 90 days series, we will be majorly focusing on important SDET interview questions. So if you have not studied the day 1, I will highly recommend you pause this particular video. In the description section, you are going to find the playlist link. Just click over there and watch the day 1 video. All right. People who have completed the day 1 video, do let me know in the discussion section that you have completed it off. And also tell me how exactly was your day. All right. So now in today's class, we will be focusing on the topic of constructor. I know what you guys are thinking. Like, Jatin, we have studied constructor a lot of time. Why are you focusing so much on constructor? The reason over here, guys, is you see this notes. These are the list of questions that I have been curating for the last 1 year. All right. And the thing over here is the topic of constructor is often asked, but it is asked in a very different way, like how people expect it is going to be asked. It's not asked like that. It's generally asked from the design pattern perspective. It is asked from your fundamental perspective. Okay, a lot of things comes over there. So we'll not just study the theory part now. We will also understand how exactly constructors are used in your project. All right, now in today's class, we will be focusing on 6 major questions. These questions are, what is your constructor? All right. The second one is going to be different types of constructor. Can constructor have a return type? Can constructor be static? Can constructor be private? And of course, most of you guys will say that yes, constructors can be private, but in which design pattern? All right. So just don't tell Singleton design pattern. There are like a lot of other design patterns in which constructors become private. So that's all we will be focusing in today's class. And we will also discuss about constructor chaining. All right. Now, the thing over here, guys, is these questions are technically related to each other. All right. So even if I want to talk about constructor chaining, you still need to know about constructor. Even if I'm talking about, constructor, you should be aware of instance variable. You should be aware of heap memory. All right. You should be aware of these object creation. All right. So the thing over here is, if you are preparing these 6 questions for you, only these 6 questions, a lot of your concepts related to your Java will be crystal clear. All right. Now, we will get started with the first question, which is constructor. Now, what I want you guys to do now is, in your own words, okay, in your notebook, write down what exactly a constructor is. Okay. Because see, I can directly start talking about constructor and all. But what is going to happen is, if you're not engaging in these sessions, okay, you're not really learning anything. All right. Or I would say it's not going to add any value to you. So what I want you guys to do over here now is go to your notebook, write in your own words what exactly a constructor is. All right. Pause this particular video, quickly write it down. I hope you guys have written it off. Now, let's get started. Even before I go into the document, I'll try to answer it in my own words. Okay. When we are talking about constructor, constructor is basically a special method. Okay. It's a special method in your class. And what is so special about this particular method? It is having the same name as that of class. Yes or no? Constructor is a method, a special method which has the same name as that of the class. Second thing, what is the job of the constructor? Yes, the job of the constructor is to initialize the dash variables. What variables? Instance variable. Yes or no? The job of the constructor is to initialize the instance variable. And do constructors have return type? The answer is no. Constructor is not going to return anything. That's the reason I said it is a special method. Constructors do not return anything. So, can we use void to a constructor? No, you can't. Alright, even void is not allowed. Alright, now, if I go to the first question, what is a constructor? Read over here. Over here, guys, a constructor is a special method in Java that is automatically invoked when an object is instantiated using the new keyword. Alright, understand this part. Constructor is a special method which is automatically going to be called. You don't need to call constructor explicitly. The moment you are creating an object of a particular class, constructor is bound to be called. Alright? And the thing is how you are going to create the object. The object creation always happens with the new keyword. Alright? Now, it has the same name as that of the class and it has no return type. Even void is not allowed. Now, the primary purpose, or I would say the job of the constructor, is to initialize the object state by initializing the instance variable. Alright, now understand this particular line. The primary purpose of a constructor is to initialize the object state. Whenever we talk about state of an object, we always talk about instance variable. Alright, we are talking about the instance variable, and the purpose of constructor is to initialize the instance variable. Now, before we go into this whole code, my next question to you is, what are instance variable? Yes, what are instance variable? Take a moment, think about it. Yep, what are instance variable? Of course, some people will say that, Arey Jatin, this name is basically an instance variable. I know that. But how do you define an instance variable? Variables which are going to be created inside the class. Alright? The variables which are created inside the class and are non-static. Variables created inside the class and are non-static, we call them as instance variable. Please make a note of this particular point. Please write this in your notebook that instance variables are variables which are created inside the class and are going to be non-static. This non-static word is important because if you are making a variable inside the class and you say that that variable is going to be a static variable, this X variable which you see is not an instance variable, it becomes a class variable. Alright, whenever you attach a static keyword, that particular variable, that particular method, that particular block belongs to the class and not to the object. Alright. So, instance variable are always going to be non-static. Okay. And again, a very popular interview question that comes into picture is encapsulation. See, whenever you are creating instance variable, instance variable are always going to have this private visibility label. Why? Encapsulation. Alright. Whenever you are going to create any instance variable, okay, unless specified, you will always mark it with private keyword. Alright. And this is again a very important question because a lot of time in interview, they ask where you have used encapsulation in your project. Now, to be honest, this is a very simple question. And people start thinking, ki Baba, where I have used it. Whenever you create Pojo classes, Sometimes you create bean classes. All right. In your test classes, if you're creating any instance variable, all right, you will always mark with a private keyword. Finish. This is the principle. And what exactly is encapsulation? What is encapsulation? Binding of variables to methods is called as encapsulation. Binding of variables to methods. Now, which variable are we talking over here? We are talking about instance variable. When you bind a instance variable to getter and setter, we call them as encapsulation. All right. Now, over here, guys, we have this constructor. Okay. What is the job of the constructor? The job of the constructor is to initialize the instance variable. Now, observe this particular code properly. Over here, guys, we have name. As I've said, name is an instance variable. Acha, tell me one more thing, guys. Instance variable are created inside which memory space? Instance variable are created inside which memory space? Instance variable will always be created inside the heap memory. It is always going to be created inside the heap memory. Perfect. Now, whenever you are creating any variable in the heap memory, name will be created in the heap memory. So this name na is always going to be initialized with default value. Not because it's an instance variable, because it is created in the heap memory. Remember it like this. Okay. Your arrays get created in the heap memory, right? So at all the indexes, okay, the values of those memory locations will always be with their default value because arrays are created in the heap memory. Okay. So if this name is going to be created in the heap memory, it is always going to be initialized with the default value. What is the default value of string? Null. The default value of string is null. This is how you're supposed to study. See, the thing is, you're not supposed to just mug up about constructor and on. The moment we started looking into the code, so many things we started to revisit, right? That, hey, I'm having an instance variable. Instance variable will be created inside the heap memory. Any variable you're going to create in the heap memory will always be initialized with the default value. And then we're looking at string name. So string is a non-primitive data type. And any non-primitive data type is always going to have the default value as null. All right. Quickly make a note of this particular point in your notebook. Pause this particular video. Quickly write it down in your notebook. All right. Now, name is having the value null. Perfect. We have a constructor. This constructor basically takes a parameter. All right. And the parameter over here is name. All right. So the constructor over here has a parameter. So tell me what type of a constructor is this? This is basically a parameterized constructor. All right. This is basically the parameterized constructor. Okay. So if a constructor basically takes a parameter, okay, then it is called as a parameterized constructor. Okay. Tell me something. Methods have parameters, right? If you're creating a method, let's say add integer a, okay, just putting one variable over here because I don't have space now, okay, and this a over here is what variable? Okay, it's a local variable. Okay, of course it's a primitive variable because int data type comes into picture, but this is a local variable. All right. So whenever you have parameters, parameters are always local variable. And local variables are always going to be created inside which memory space? Yes, which one? They're always going to be created inside the stack memory. Make a note of this particular point. See, this is the main method also. So over here we have this p variable. This is also local variable. This is going to be created inside the stack memory. New person is there. This is what? The object. You see the new keyword. It means it's talking about the heap memory. Objects are always going to be created in the heap memory. Instance variable will be created in the heap memory. And variables which are created inside the method, variables which are declared inside the method, they are always going to be created in the stack memory. Parameters are always local variables. Is this part making sense to everyone? Perfect. Now, let me just rub this particular chap quickly. Over here now, guys, see, we have this constructor which basically takes a parameter called string name. And we know that this is a local variable. Now, observe carefully, which is really interesting, that we have an instance variable and we have a local variable. These both chaps have same name. Okay, name and name. All right. So, instance variable is also having name. Your constructor is also having a parameter. That is the local variable. This is also having the name. So, how exactly Java is going to differentiate between them? That's where this keyword comes into picture. Okay? This keyword comes into picture. What is the purpose of this keyword? This keyword is used to differentiate dash and dash. Local variable with instance variable when they have same name. Are you getting the point? The purpose of this keyword is used to differentiate a local variable with instance variable when they have same name. So when you're talking about this dot name, it is talking about this variable, and we're just talking about name, it is talking about this chap. All right, are you getting the point over here? Now, I'm going to give you a very simple example. Let's assume your name is Shahrukh and your mama calls you Shahrukh. Okay. Then, is she referring to Shahrukh Khan or is she referring to you? She's referring to you. All right. Even though there are two entities which have same name. Okay. The scope defines which is going to have a better or more priority. Inside your house, in your house, you are having the higher priority. All right. So when she's calling Shahrukh, she's not calling Shahrukh Khan, she's calling you, right? And when she has to refer to a bigger entity, she has to take a full name. All right. So when you're talking about this dot name, it refers that you're talking about the instance variable. Are you getting the point? Okay. That's the whole thing. Okay. So this is what we have over here. All right. We have this public class person, which basically has this instance variable name. And we have a parameterized constructor. And the job of the constructor is to initialize the instance variable. So here you will notice that when I am trying to create an object of person class, I am passing some value Jatin. This value Jatin is going to be given to this local variable. From this local variable Jatin is going to be given to the instance variable. Makes sense? Perfect. So that's what constructor is. Read this particular 3 lines again properly. Constructor is a special method in Java that automatically gets invoked when an object is instantiated using the new keyword. It has the same name as that of the class and there is no return type. Even void is not used. Perfect. The primary purpose of the constructor is to initialize the object state. When we are talking about object state, we are talking about the instance variable. And it initializes the instance variable. What constructor initializes your instance variable? Perfect. Now, over here, this is the first question. The next thing that you should be aware about constructor is what are the different type of constructor. When we are talking about constructors, there are three main type. One is a default constructor, second one is a parameterized constructor, and third one over here is a copy constructor. So we will be understanding these three type of constructor. All right. So if an interview they ask you what are the different types of constructor, what are you going to say? We have three types of constructor. We have default constructor, we have parameterized constructor, and we have copy constructor. So let's play with these three types of constructor. So before discussing this particular code, I would like to write this particular code on my Eclipse. And all I want you guys to do is just observe my screen. So over here, guys, we're going to quickly create a class. Let's call this particular class as a person class. And inside this particular person class, guys, what I'm going to do is I am going to have this instance variable called name. All right. That's it. Now, over here, let's introduce a toString method. So people who know what exactly a toString method is, a toString method is going to give me one line description of the state of the object. So if I am going to go to this generate toString method, I'm going to click on generate. This is the method which is creating. So what it is going to do, it is going to print me the value of name for a particular object. So let's quickly create a runner class. I'm going to right click, new, create a class called runner. And let's introduce this public static void main method. Control Shift F, save it. Let's remove this chap. And I can simply say person P1 equal to new person. All right. Now over here, guys, notice. If you notice this chap, now what is this? This is the object. How do I know this is the object? The new keyword comes into picture. What happens when you create an object? Yes. What happens when you create an object? Whenever you're creating an object, three things are bound to happen. What are the three things? Class is loaded into memory. Okay? Class is loaded into memory. Second, instance variable is created. Instance variables are going to be created where? In your heap memory. And third thing, your constructor is called. All right? So whenever you are creating an object, three things are bound to happen. Class is going to be loaded into the memory. Now tell me inside which memory this class information is going to be loaded. Yes, method area. Okay. So inside your method area, you have your static variables, your class information, all those things are going to be loaded in your method area. Instance variable will be created in the heap memory, and then what is going to happen? Your constructor is going to be called. Now observe one more thing over here. We have this person P1 equal to new person. Now, this is a method, right? This is a method. So person P1, what do you call this? This is what we call as declaration. Declaration of this particular variable is happening inside a method, not inside the class, inside the method. This is the code block. Na? Inside this code block, the declaration is happening. So this is a local variable. You see this new person, na? New person. The moment you see new keyword is always going to talk about your heap memory. What memory? Heap memory. So object is always going to be created in the heap memory. So this is my stack, and this over here is my heap. Now, over here, whenever your method is going to be executed, that method is going to enter inside the stack memory. All right. Method execution always happens inside the stack memory. And when Java sees person P1 equal to new person, what is Java going to do first? This is my LHS. This is my RHS. Whatever is going to be on the right hand side is always the RHS. Whatever is going to be on the left hand side of the equal to is the LHS. So when you see this new person, all right, which is on the RHS, Java is always going to execute the RHS first. All right. When Java sees this particular statement, it is going to always execute the RHS. Right hand side is always going to be executed first. Variable declaration over here is going to happen later. Now, over here, Java sees this particular stuff, new person. What is this? This is an object. So whenever you are creating an object, three things is going to happen. Class is going to be loaded into the memory, technically in your method area, done. Then instance variable will be created inside the heap memory. And third thing, constructor is going to be called. So over here, your person object is going to be created. And this is the instance of the class. Object is an instance of a class. And over here, you will be given name. Now, name is what? An instance variable. Instance variable is going to be initialized with the default value. What is the default value of your string? Null. So over here, null is going to be there. All right. Now, this whole thing now is going to have some unique identification. All right. So let's assume that is 777. All right. Now, over here, understand this part carefully. Class got loaded into the memory. Instance variable got created. This is my instance variable which we have created in the heap memory. And now the constructor is going to be called. Over here, if you observe, we don't have a constructor. Right? We don't have a constructor. But still, even if you don't have a constructor, Java is going to call a default constructor for you of person class. Observe carefully. If I hide this new, it looks like a person method is getting called. Na? But I don't have any person method. Yet, Java is going to create one and it is going to call that one. That is a dummy constructor. So, this what you see na, is looks like a default constructor. Now, just to show you what exactly a default constructor is basically a special method which has the same name as that of the class. This is your default constructor. All right. A constructor which does not take any parameter. A constructor which does not take any parameter is basically a default constructor. All right. Most of the time, you don't need to create a default constructor. Our job over here in our framework, in our project is to create a parameterized constructor. Why? Because for us, it is important that we initialize the instance variable. Are you getting the point? This is what we want. So over here, we have this default constructor. Now inside the default constructor, I'm writing nothing. So even if I add it or even if I don't add it, Java is going to create one. So if I go back to the runner, all right, and I just do system.out.println P1, say this, right click, run as Java application, you will notice that, hey, there is a person object, all right, and the instance variable name has the value null. Does it fit the definition? Let's see. Over here, right now, this person object is having name as null. All right. Now, we did not create the constructor, yet Java created one and called it. So, technically, it was like this only. This is what Java created. But let's say if you would have created it something like this and you could have written something like this, and I could have said, hello. All right. Observe the difference now. Now, I have created a default constructor which is going to print this particular line system.out.println hello. So, if I go back to the runner, right click, run as Java application, the output will be hello, and then it is going to print the state of the object. All right. Most of the time, Okay, most of the time, the job of the constructor is not to print messages and all. All right. So when people are learning, they're like inside the constructor, they're just going to print it off. You can definitely do it, but that's not what the whole job of the constructor is. The job of the constructor is to initialize the instance variable. So the first type of the constructor that we have is basically this default constructor. Either you create it or Java is going to create one for you. Let Java create it for us. But here is the most important thing. The most important constructor in our automation framework is going to be the parameterized constructor. All right? The most important constructor in our automation framework, in our Java development, is going to be the parameterized constructor. So over here, guys, what I'm going to do is I'm just going to go to right click, source, generate constructor using the fields. Just to show you again, right click, source, constructor using the fields is going to generate a parameterized constructor, and I'm going to click on generate, done. All right. So this chap, what you see now, this is the parameterized constructor. Let me delete this chap. This is the parameterized constructor. Are you getting the point? Why? Because it is taking a parameter. Look carefully. Array, I have an instance variable which has the name. I have a parameter which has the name, your instance variable and your local variable, because parameters are local variable. Now, in this particular method, in this particular block, I want to access the instance variable. Along with that, I want to access the local variable. So, what? Whenever you want to differentiate instance variable with local variable, you are going to use this keyword. All right, write it down in your notebook. This keyword is used to differentiate instance variable and local variable. Okay, when they have same name. Is this part clear to everyone? Perfect. Now, the moment you are saying this dot name, Java will refer to this chap. All right. So we have a default constructor and we have the parameterized constructor. Now understand this thing very carefully. If I comment this now, Control Shift C. Now what do I have? I just have a parameterized constructor. Previously, our code was working because if we were not creating any constructor, Java was creating one for us, the default one, right? Now, this time we have created a parameterized constructor. If you are creating a parameterized constructor, my dear friends, then you are supposed to call it explicitly. If your Java class is going to have a parameterized constructor, you are supposed to call it explicitly. So over here, you see the constructor person is not defined. But if I'm just going to remove this round bracket and I'm going to do a control space, all right, you're going to do a control space and you will notice that I am getting this constructor call which takes a parameter call string name. Right? So the thing over here, guys, is if your class is going to have a parameterized constructor, all right, if your class is only having parameterized constructor, you need to call it explicitly. Now I cannot do this. Java will not create a default constructor and give it to me. Why? Because you have created one parameterized constructor, na? So it is your job to call this constructor. Now, the thing over here, guys, is when we have this parameterized constructor, to this parameterized constructor, you are going to pass what value you want to initialize your instance variable with. So here you see I have string name, right? So it is highlighting me that, okay, whatever the value that you are going to put over here, that is for your name variable. So here I'm going to give it as Jatin, put a semicolon, save it. Let's click on the play button. Let's bring this chap over here and you will see that our object is having the value of name as Jatin. Is this part clear to everyone? Perfect. So just to explain you the execution of this particular program, this is a method. Method execution is going to happen inside which memory space? It is going to happen in your stack memory. All right. Remember that part. Whenever there is any method, method execution is bound to happen in stack. So let's create a stack. All right. Java is going to execute the main method, meaning main method is going to be loaded inside your stack. Perfect. Now, line number 6, nothing to do. Line number 7, person P1. This is a declaration. So this declaration of this variable P1 is happening inside your main method. This is a local variable. Now, there is an equal to sign. This is the LHS. This is the RHS. Java will execute what first? LHS or RHS? Always the RHS. Perfect. So, Java sees new person and then there is a round bracket. You're passing the value Jatin. The moment Java sees new keyword, it understands ki Baba, you are talking about heap memory. All right. And it is going to create an object of person class. Whenever you are creating an object, three things are bound to happen. Class is loaded into the memory, instance variable is created, and the constructor is called. Class is loaded into the memory. Only for one time that happens. Class loading happens only for one time. Done. The second thing, instance variable is going to be created. Boom. Name. Name is going to be initialized with the default value. Why? Because name is getting created in the heap memory. So over here, this is going to be null. Third thing, constructor is going to be called. Now look carefully. If I just hide this new keyword for you guys and just focus on this chap, does this look like a method call? Yes or no? Method call is going to happen where? Method execution happens where? Inside which memory space? Inside your stack memory. So over here, my dear friends, your person method, a special method of your person class called person will be called, which is taking what? String as a parameter. So over here, guys, if I go back to the person class, my question to you guys is, when you look at this chap over here, I'll highlight it over here. String name, this is a parameter. Parameters are what kind of variables? Local variables. Local variable to be created where? Inside your stack memory. So over here, name will be created. All right. Name was passed a certain value, na? Jatin. So this is Jatin. Now, observe. There is a name variable which is inside the stack memory. There is a name variable which is there in the heap memory. Now, when you're talking about just name, Java knows that you're talking about the local variable. But how do I refer to the name variable which is there in the heap memory? That's where this keyword comes into picture. So when you say this dot name, you are referring to your instance variable. All right. So I hope visually you are able to connect to this now. So when you say this dot name, you're talking about this. Now, some of my friends will say that, Ari Jatin, why can't we have different names then? It becomes overcomplicated then. All right. You have to keep on doing the mind mapping then. See, if I am using the same variable name, whenever I'm going to do a object creation, you see that I was getting this particular suggestion, string name. So I know now that this name, what we are talking about is the instance variable, right? Whatever the value I'm going to pass, eventually it is going to reach to the instance variable. Why it is going to reach to the instance variable? What is the job of the constructor? To initialize the instance variable during the object creation. Everything in life is connected, guys. This is why we have the same name. All right. This is what you call as fundamentals. Okay. And you really can't change all these things. You have to be really good at these things. Mugging up topics really don't help. Okay. So when I say person P1 equal to new person Jatin, now when I am printing, what you see, the instance variable is having the value as Jatin. Let's create another object. Person P2 equal to new person Uday. So I'm going to do sys out P2. Alright, sys out P2. If I want to click on this chap, the second object over here has the value of name as Uday. So what is happening over here? We are having two objects of person type. This was person, the first one whose value is now Jatin. This is the second object of person. Value of name is Uday. Alright. Now, object is what? Instance of a class. We generally say object is a real world entity. So there are two people. Alright. One person has the name Uday. Other person has the name Jatin. Are they same? No, they are two different. They live in two different houses. So they are two different people. They will occupy two different memory space. Alright. So once this is done, acha, we're talking about person P1. Once your object creation happens, once this whole stuff is done, once your object creation has been done, alright, then Java is going to create P2, P1 and P2. And it is going to be created where? Inside your main method, because it's been declared over here, inside the main method. So P1 is the reference variable for this chap, and P2 is the reference variable for the other person object. Are you getting the point? So these two are two different objects. They are not same. Is this part clear to everyone? Yes or no? Right? Now, let's talk about the third type of your constructor. What is that? Any guesses? Copy constructor. What? Copy constructor. The third type of the constructor that we have is a copy constructor. We started with a default constructor. Then we saw parameterized constructor. Let me just write it down over here. Parameterized constructor. And the third type of constructor that we have, guys, is copy constructor. Now, what is a copy constructor? Very simple. Don't mug up. Don't mug up. When you look at these two output, person name equal to Jatin, person name equal to Uday, are they same or they are different? They are different, right? Now, I want to create a deep copy, meaning I want to create another object which is going to have the same values of this name variable for Jatin. Alright. So, create another object of person class, and the value of the instance variable should be same as this particular object. So how to do that? That's where copy constructor comes into picture. With the help of copy constructor, you can create copy of a particular class object. That's all. So when you're going to say person, it is a parameterized constructor, but the USP, the speciality of this particular constructor is it is going to take the reference. Okay, it is going to take the reference variable of same class. Person reference. Alright. You are creating a constructor. Alright. What is this P1? What is this P2? They are reference variable, na? They are reference variable. So, a copy constructor is a constructor. This is a constructor which is a special parameterized constructor which takes the reference of the same class. Alright. And with this chap, we can create a deep copy. Done. Look how? Observe carefully. Now, I'm just going to do person P3. And what I want, person P3. Okay, this new object which is going to be created should be a copy, a deep copy of our person Jatin object. All right. I'm just gonna do this new person, and it requires a person reference. So I'm gonna just pass P1. And now if I do this, all right, save this. So this and this, they are same. I mean, like they're two different objects, but they have the same value. This is what you call as a deep copy. All right. This is what you call as a deep copy. Is this part clear to everyone? Perfect. Now let's go to the notes. Over here, guys, question number 2. What are the different types of constructor? In Java, we have 3 types of constructor: default constructor, parameterized constructor, and copy constructor. Look at the code. We have a person class. Inside the person class, we have an instance variable called name. We know that name is going to be created in the heap memory. And name is going to have the default value as null. Now, default constructor, either you can create it or Java will create it for you. If you don't have any other constructor, parameterized constructor and copy constructor should not be there. If these two chap is not there, so whether you create this or whether you don't create it, Java will take care of it. All right. But if you are going to have any of these two, either you have a parameterized constructor or a copy constructor, then you are supposed to explicitly call it off. All right. Now, in your project, all right, let's say you are creating a Pojo class, whether you're creating a Bean class, all right. If you are going to have an instance variable, you will create a parameterized constructor. Make a note of this particular point. If your class is going to have an instance variable, you are going to create what? A parameterized constructor. 100%. Okay, you cannot run away with that. All right. So, a default constructor is a constructor which does not have any parameter. All right. And technically, I don't know. Like if you want to have it. Most of the time you just use a parameterized constructor. It is better compared to your default constructor. Now, when you have your parameterized constructor is going to take your instance, it's going to take parameters, all right? And whatever the parameters you are passing, the job is to initialize your instance variable, all right? Again, in your parameterized constructor, you're going to get a new interview question. What is the purpose of this keyword? This keyword is used to differentiate local variable with instance variable when they are going to have same name. There are a lot of other things about this keyword, but for now, you just remember this thing. Then you have copy constructor. Copy constructor is one which takes the other object reference as parameter. All right, this is something that you should be knowing. So if I'm going to create a copy constructor of my person class, I have to put a reference of the same class, and it is going to just initialize, or it's going to create a deep copy of our existing object. All right, that's all. So over here, this is what, we have a sample code. We are creating the person object. Then this is with the default one. Then this is going to be with your parameterized constructor. And over here, we are creating a deep copy. So when I'm going to do p3.display, it's just displaying the name. So even for p2 and p3, the name will be Jatin printed on the console. All right. Is this part clear to everyone? Perfect. Now, let's just read these points over here quickly. Default constructor is basically called as a non-argument or no argument constructor. This is automatically provided by Java if no constructor is explicitly defined. All right. If you guys have the notes, great. You can go through it. If you don't have it, please write it down in your notebook. This is the time to study. All right. The more you keep on recollecting the points that you have studied, you will be much more comfortable as well as confident in your interviews. All right. So over here, when we are talking about a default constructor looks like this. All right. Once you define any constructor, a parameterized or default, Java no longer provides the default constructor. If you have created the default constructor, then Java is not going to create one. If you have created the parameterized constructor, Java is not going to create the default constructor. Are you getting the point? Next, parameterized constructor. A constructor that accepts parameter to initialize the values of the instance variable is called as the parameterized constructor. This provides flexibility in object creation as we pass value to the instance variable during the constructor call, and it is crucial for dependency injection. You want to make a note of this particular point. Okay. You want to make a note of this particular point. The purpose of your parameterized constructor is to help in dependency injection. Next one comes into picture is copy constructor. A constructor that takes the object of the same class as a parameter is called as a copy constructor. So when I say person P1 equal to new person Raj, and when I'm saying person P2 equal to new person P1, so over here, this P1 reference, we are passing it off. P2 is technically a clone of P1. Okay. You're creating a clone. Control C, Control V. That's it. This is useful for creating deep copies or cloning objects with specific modifications. Is this part clear to everyone? Now, one bonus question. If you're talking about copy constructor, okay, this is how you should also prepare for interview. Once you know that your interviewer is going to ask you about constructor. Okay, let's say they ask you about this particular topic of constructor. The next thing, you know that you're going to say about default constructor, parameterized constructor, and your copy constructor. The moment you are going to use the word deep copy, okay, be ready, because they can ask you what is the purpose of shallow copy, the difference between deep and shallow copy. So this is going to be more like a bonus question over here. When we are talking about shallow copy, shallow copy is what? You are creating person P1 equal to new person Jatin. All right. And this is person P2 equal to P1. Okay. So this is not going to create a new object. This is not going to create a new object. Technically, you have two references which points to the same object. Okay. You are creating two references which are pointing to the same object. So if I do any modification to this particular object, all right, that modification is going to be shown for both P1 and P2 because technically they are pointing to the same object. When you are doing a deep copy, you are technically creating two different objects. Okay, you have two objects and they are technically equal at the start. If I do any modification to this one, it is not going to reflect to this one. Are you getting the point? When you create, I'm going to give you a very simple example. Let's say you have a document. All right. Your resume. You do a Control C, Control V. You create a copy. Right. Let's say you're modifying the first document. So the changes that you have made in the first document, will it reflect in the second one? No, nah. It's not going to happen. Right. So in your deep copy, we are technically having two different objects. Okay, in shallow, we have one object and there are multiple references. Both object reflects the same change. Object becomes independent. Okay, in deep copy. All right, I hope this particular part is clear to everyone. Now, let's read question number 3. Can constructor have a return type? All right. Can constructor have return type? Yes or no? No. Constructors don't have return type. Even void is not allowed. Now let's read on this particular stuff. No constructor cannot and should not have any return type, not even void. Now the next thing the interviewer can ask is what is going to happen if I put void or any return type next to the constructor? This is important. Read over here. If you add a return type to a constructor, Java is going to treat it as a regular method that happens to have the same name as that of the class, but it won't be invoked during the object instantiation. Okay, take a moment, read this particular line. If you add a return type to a constructor, Java is going to treat it as a regular method. It is not going to treat it as a constructor. And this regular method happens to have the same name as that of the class, but it won't be invoked during your object instantiation. Make sense? Perfect. Now guys, let's move on to the next question. Can constructor be static? Most of us know that constructors cannot be static. Why? The simple reason over here is whenever you are making any variable, any method as static, it belongs to class. All right, it belongs to class. When you're talking about constructor, the job of the constructor is to initialize the instance variable. The name itself says instance variable. Object is an instance of the class. So whenever you are creating an object, what happens? Class is loaded into the memory, instance variable is created, constructor is called. So the constructor is bound to an object creation. All right. And static variables, static methods, static block belongs to the class. So they will be created and initialized only and only once. But you can always keep on creating n number of objects. So if you're creating 10 objects, 10 times the constructor is going to be called. Are you getting the point? Let's read these 4 points. No constructors cannot be declared static in Java. Whenever you create an object, the constructor call is bound to happen. This would be a contradiction in terms because static variable belongs to a class rather than any specific instance. Static variables are always going to be shared across multiple objects of the same class. So whenever you want to share data between the objects, make that particular variable as static. All right. While constructors are specifically designed to create and initialize the instances or your instance variable. Constructor belongs to the instances. Constructor belongs to an object. Pretty simple, okay? But in interview, it is really important that how you're articulating it, okay? You have to sound technical. Is this part clear? Please read these 4 points quickly. I hope you guys have gone through your question number 4. Now, let's talk about your question number 5, which, to be honest, is a very important interview question. It has been asked a lot of time. Okay, of course, the structure of the question will be a little bit different. Sometimes they will ask, tell me about the different design patterns you have used. Sometimes they will ask, have you made your constructor private? If yes, where? Third, can constructor be private? All right. So most of the time when people are learning Java now, they always make the constructor and they notice that the constructor is always public, right? The main thing that happens, okay, is people don't ask that, hey, can constructors be private? And the simple answer is yes, constructors can be private and it should be private in specific design patterns. All right. Now, most of the time, when the interviewer asks, tell me the various design patterns you have used in your automation framework, everyone is aware of what? Your page object design pattern. But apart from that, there are many other design patterns to really use in your project. Now, in simple terms, if I have to explain you what is a design pattern basically helps in implementing your object-oriented concepts properly. So again, in interview, they ask this particular question, how did you ensure that you have used or implemented object-oriented programming properly? Right? What are you going to say? You have used design patterns. You made sure that you're using design patterns. Okay. So over here, guys, yes, constructors can be private and they are private in certain design patterns. Now, what happens when you make a constructor private? Read this particular line. A private constructor prevents direct instantiation of the class from outside, but within the class you can create the object. Whenever you are making the constructor private, you cannot create the object outside the class. Alright? Whenever you are creating the constructor, you are making the constructor as private, you cannot create the object outside the class. Read between the lines. But within that class, I can create the object. Let me show you over here. Observe carefully. Over here, guys, if we go to this person class, we have your default constructor, parameterized constructor, and copy constructor. Now, I'm going to do a control shift C and I'm removing all the constructors. All are commented now. But still this particular code, now you see is there. Let me just comment this chap. And what I'm going to do, I'm going to quickly create, one of this reference. And let's remove this P1. Okay. So over here, guys, let's save this. Yeah. Over here, we are able to create the object and the constructor is definitely getting called. Why? Because even if you don't create the constructor, Java will create a default constructor for you. Now, I am going to make the constructor private. So I'm going to say private person. All right. So yes, my constructor became private. So constructors can be private in Java. When you make the constructor private, what happens is you cannot create the object outside the class. I am in the runner class and I'm trying to create the object of person class. This is not allowed. The moment you make the constructor private, you are taking away the power of creating the object outside the class. Then what we are supposed to do? If you want to create the object, you are supposed to create the object inside the same class, because private variables and private methods can be accessed within the class. You cannot access it outside the class. So I'm going to say person p equal to new person. None. You see, object creation is happening within that class, but outside the class, I'm not able to do it. Now, the question that most of you guys will be thinking, where I'm going to use this particular stuff in our project? That's where the whole design pattern concepts comes. You have your utility design pattern, you have your singleton design pattern, you have your factory design pattern, all right, builder design pattern. So there are 4 main design patterns where you generally make the constructor as private. This is something that you want to make a note of this particular point. All right, let's go back to the notes over here. Over here, guys, when we are talking about design patterns, okay, and where constructors are going to be private, the first one is going to be the singleton design pattern. Most of you guys have definitely heard of this particular term singleton somewhere on the LinkedIn, or you would have watched a YouTube video on it. Now, when you are talking about singleton class, singleton class basically means you can only have one instance of that particular class. That's it. Singleton means what? Only one instance is allowed. Can I have 2 instances? No. Instances means can I create 2 objects? No. Only one object. So if you want to create only one instance and you want to ensure that no matter how many time people are trying to consume this particular class, you are only having one instance and one instance is getting accessed across your entire project, singleton design pattern comes into picture. Where you're going to use the singleton design pattern in your framework? It is generally used in components like your database manager as well as in your config manager. Config manager, you're trying to read the properties file, right? That's where your singleton design pattern also comes. So when you want to exactly have one instance of a class in your application, that's where singleton comes into picture. Then in interview, they can also ask where you have used singleton. So just remember, you have used it in database manager and config manager. All right. And the next design pattern is basically the utility design pattern. Utility design pattern is pretty simple. Create a class, and inside that particular class, you are going to have variables and methods as static. Create a class. Inside that particular class, you have variables and methods as static. Now tell me something. If you are having a class which has variables and methods as static, should you create the object of that class? No, no. You can access the variables and methods provided the variables are public. I can access the variables and methods outside the class just using the class thing, because static variables and methods don't require object creations. So in your utility design pattern also, we introduce private constructor so that people unknowingly do not create the object of that class. Now you can have a lot of utility classes in your framework. You're creating a utility for Excel reading, you're creating a utility for database connectivity, you are creating a utility for reading JSON file, you're creating a utility for Faker, a lot of places where utility comes into picture, right? So you are definitely going to use utility design pattern. Now, just read these points. Classes with only static methods like your math, collection or custom utility classes that you have should have private constructor to prevent meaningless initialization or instantiation. If you plan to create any utility class which has all the methods as static, make sure to make your constructor private. Is this part clear? All right. Now let's move on to the next one, which is the builder design pattern. Again, in interview, they can ask the question where you have used builder design pattern in your project. So if you have used rest assured, response spec builder and your request spec builder, these are the two places where builder design pattern usually pops up. Again, it's a very useful design pattern. And in your builder design pattern also, we generally have private constructor for the outer class. All right. Just read these 2 points. That is more than enough because we're just talking about constructor. If a class has a lot of instance variable, then object creation is going to be a bit difficult. Okay. And it's going to be complex because constructor will have a lot of parameters. So inside your class, if you have, let's say 10, 15 instance variable. So of course, you're going to have a parameterized constructor. So that constructor is going to have 10, 15 parameters. So it looks a little bit overwhelming. And sometimes you don't need all the parameters also. All right. So if you want to just make the object creation a little bit smooth, all right, you can use builder design pattern. In your builder design pattern, we generally have an outer class, and in that outer class, we will create an inner class. All right. And the outer class is going to have a private constructor. Builder pattern is used to create complex objects step by step to avoid constructor explosion, makes the object immutable. So, all the instance variable of your outer class are going to be final. All right. And with the help of builder design pattern, technically the readability and the safety of object creation is there. That's something that you achieve with your builder design pattern. Next is your factory design pattern. All right. In factory design pattern also, you have your constructor becoming private. Okay. Now read this particular point. When you want to control the object creation through factory methods rather than direct instantiation, you are going to use factory pattern. Now, most of you guys definitely would have written this particular code, right? Look at this particular code. Browser.equal Chrome, you are going to create the Chrome driver object. If it is going to be equal to Firefox, you are going to create the Firefox driver object. Or if it's going to be Edge, you are going to create the Edge driver object, right? Now, you can actually introduce a driver factory. So this code which you see can be written in a much more better way using your factory design pattern. And over here in your driver factory, I am just creating a private constructor. And what this get driver method is going to do, it is going to return me web driver reference. Okay. So if you are going to give me whatever the browser is, it is going to create the object, okay, of the respective driver, and it is going to return us that. So when you are trying to use this, okay, you want to have probably, let's say, Chrome browser. So what I'm going to do is I'm going to write web driver, because we are getting web driver over here, na? Web driver WD equal to driver factory dot get driver, and you are going to give the stuff over here, let's say Chrome. All right. Observe this particular line. Do you see I am doing any constructor call? Am I creating the object of driver factory? No, it's not required because this particular method is static. This particular method is going to take care of whose object is going to be created, and it's just going to return us that reference. All right. And the constructor over here is private, meaning even if you want to, you can't. Meaning even if you want, you can't call the constructor outside the class. All right. Is this part clear to everyone? Perfect. Just read these particular points, builder pattern and factory pattern. If you haven't made the notes, quickly make it off. All right. I hope you have done so far. Let's move on to the next page. All right. What is constructor chaining? The last question for today, guys. What is constructor chaining? When one constructor calls another constructor, that's called as constructor chaining. Simple, that's it. When one constructor calls another constructor, it's called as constructor chaining. In Java, you can do constructor chaining using two special keywords. What are those two keywords? This and super. We saw this keyword, we were using this keyword to differentiate local variable with instance variable. But this keyword is also used to call the constructor of the same class. Observe carefully over here. Now, over here, we will try to do constructor chaining. So, what I'll do is I just remove this particular code and I'm just going to uncomment this chap, Control Shift C. Let's remove this, Control Shift C. Let's remove this extra curly. Let's go back over here and Control Z, Control Shift C. Oopsie. Let's uncomment it, though it's not working for me. All right, let's remove it off quickly. All right, Control Shift F. Now, over here, guys, what we want is we want to do constructor chaining. So we have this person constructor, which is the parameterized constructor. Observe carefully. If I want this parameterized constructor to call the default constructor that we have created, I can do that with the help of this keyword. Done. And I can remove this line. All right. Observe what has happened. So, when you write this round bracket, is there a constructor which does not take any parameter? This one. So, this is going to call the default constructor for us, right? And over here, guys, I have this chap now. I want this particular chap to call this parameterized constructor. Can I do that? Yeah, you can do that. I can say this round bracket reference dot name. All right. So when one constructor, this is that constructor, calls another constructor, okay, it's called as constructor chaining. Now, what is happening over here now is we are calling the constructor within the class. All right. So we have multiple constructors. So one constructor is calling the other constructor, but it's within the class. So if inside the class you want to call some other constructor, you can use this keyword. But when you are going to have a inheritance or child-parent relationship, so over there, if the child class constructor is going to call the parent class constructor, that is going to happen with the help of super keyword. All right. So with the help of super keyword, I will be able to call the parent class constructor. Is this part making sense to everyone? All right. Now let's try to see whether it works. So over here, you will notice that I am calling new person Jatin. So technically, it is going to create the object with a parameterized constructor. And this chap internally is going to call the default constructor first. So hello will be printed first on the screen. And then it is going to initialize the instance variable with the value name as Jatin. All right. Let's say this. Let's go back to the runner. Let's bring this guy up, right leg run as Java application, and you will see hello is getting printed for all the parameterized constructor. All right. Is this part making sense to everyone? Perfect. Now here also, this is the copy constructor. Na? So if you go to new person P1, over here, internally, it is calling your parameterized constructor, this chap. This parameterized constructor internally calls your default constructor. That's the reason hello is getting printed for this also. All right. Is this part making sense? Okay, that's it. Now let's go back to the document and read these lines properly. Constructor chaining is the practice of calling one constructor from another constructor within the same class or from the parent class. So constructor chaining is going to happen with the help of two keywords. This is something that you need to remember. And if you want to call the constructor within that class, use this keyword. If you want to call the parent class constructor, you're going to use the super keyword. All right. I hope this particular part is clear to everyone. So that's it, guys. Time's up for today. In today's class, we majorly focused on these 6 questions. There is going to be a bonus lecture which I'll be keeping in the members only. So if you want, you can definitely check those lectures. In those lectures, we will majorly be discussing on these design patterns. All right. So if you are free, definitely check that. Now I'm going to see you guys in the next one. Don't forget to mark your attendance. Go to the comment section and write it down that you have completed the video so far. And do let me know how was this lecture. All right. So that's it. Now I'm going to see you guys in the next one. Till then, take care. Bye-bye.